Okay, everybody, here we have this podcast on set theory. There's going to be a lot of writing to do on the notes with this podcast, so make sure you pause it as we go, or listen to it, then go back and pause it so you can write everything down. Alright, so the first part will be a review. So our first vocabulary word is a set, and we learned on the last podcast that a set is a collection of elements. Okay? Some examples of sets. So in your section where it says examples, write 2 or 3 of these that make the most sense to you to help you remember this. Alright, so like the All-Star team or the Navigators team at Liberty would be an example of a set where all the students and teachers would be elements. Redskins, the players would be the elements in that set, etc. Okay, so fish in a pond, books in your locker, odd numbers or even numbers would be a set. Like if odd numbers were a set, the elements would be 1, 3, 5, 7, 9, so on. Multiples of 5, shoes in your closet, students see lunch. Alright, so those are examples of just simple sets. A subset. Okay, we talked about it, but here's the official definition for you to write down here. Alright, a subset, we would say set A is a subset of set B if every element in A is also in B, and if there is no element in A which is not in B. I know that's a lot to digest, so we'll say it again, read it to yourself, but it's set A is a subset of set B if every element in A is also in B, and if there is no element in A which is not in B. Okay? This is written as, this is how we say A is a subset of B. Okay? With that symbol right there. Alright, so some examples of subsets. The All-Star team or the Navigator team is a subset of Liberty. Okay? Because everyone that's in the All-Star team or the Navigator team is also in the set of Liberty. Okay? The Redskins are a subset of the NFL. Every player on the Redskins team is also a player in the NFL. Everything in that first set is in the second set, therefore it's a subset. Odd numbers are a subset of the integers. Liberty is a subset of Fairfax County Public Schools. Okay? So on this part, write these down for the examples here. Okay, this is all one example. Set A equals 1, 2, 3, 4, 5. Those are the elements. Make sure you have your braces. Set B, the elements are 1, 2, 3, 4, 5, 6, 7. Okay? And at last it has the notation set A is a subset of set B. Okay? You'll notice that based on the definition, it says every element in set A is in set B. So if you go look, I'll mark this for you. Every element in A is in B. You can see that, right? And it says there's no element in set A that's not in set B. So there's nothing left in here that's not in here. Therefore, it is a subset. Okay? Let's look at the second example. Set A, the elements are 2, 4, and 6, and set B, the elements are 2, 4, and 6. So once again, by definition, every element in set A is in set B, and that's correct. Therefore, set A is a subset of set B. Now, one thing that you're probably noticing here is you're probably saying, hey, this is kind of weird. It's the exact same set. Okay? But by definition, that is still a subset. Let's add this to your notes here. Okay? Because you'll notice these are different subsets, or they work differently. This example is called a proper subset. Alright? And a proper subset follows the same definition as here, except for it states that set B has to have at least one element that's not in set A, which technically makes it bigger. So that's why this is a proper subset. This is a subset but not a proper subset because there's nothing in set B that is not in set A. Okay? Alright, and lastly, let's put one non-example here. Alright, we'll make this one short too. So if set A has elements 2, 4, 6, 8, and 10, and if set B has elements 4, 6, 8, 10, would you think that's an element? Yes or no? Would set A be a subset or not of set B? And the answer would be no, because although almost everything in set A is in set B, this 2 is in set A, but it's not in set B. So therefore, this is not a subset of this. When something is not a subset, we use the same subset symbol with the slash through it. Okay, so that's how we would handle that. Alright, next vocabulary word is the empty set. And this is a set that contains no elements. And it's also called the null set. Okay, so it is what it says. It's an empty set. There's no elements. And there are two ways to write the empty set. Sometimes you'll see it written as the braces with nothing in it, or this symbol for null. Okay, so here are some examples of empty sets. So if you think about our math class, if we said the set of 8th graders in our class, that would be an empty set because we don't have any 8th graders. Okay, if we say yellow lockers in the A pod or B pod, once again that would be an empty set because there are no yellow lockers, they're all blue. Okay, students in this class with a pet elephant, most likely that's an empty set. We wouldn't be able to list any students with a pet elephant. Okay, and same thing with multiples of 5 that have units of digits of 3. Okay, want to add on a quick note here, if you can add this to your notes as well. Okay, the empty set is a subset of every set. Okay, so once again, no matter what the set is, the empty set is technically a subset. Okay, because the empty set does not take up any space. You know, therefore it's kind of like there's space in every set. So that's just one of those constant weird rules. Empty set is a subset of every set. Okay. Alright, next we have the universal set. The universal set, which they always denote as a uppercase U, represents all sets under consideration for a given situation. Alright, so that's what the universal set is. For example, if when we talk about the real number system, you know, we have all the subsets: natural numbers, whole numbers, integers, rational, irrational. The actual set of real numbers would be like the universal set because that set has everything in it. Okay, so that's an example of the universal set, the real number set. Alright, going on to union. Alright, the union of A and B, or sets A and B, is the set of all elements in the universe belonging to A or B or both. That's key here. Okay, so it's everything that's in A or everything in B or both, because you're putting them together in a union. Okay, so the key word here is or, and this is written that this is how you say set A union with set B. Okay, that's the symbol right there for union. Alright, so some examples of sets in a union. If we take the set of 7th graders and put them in union with our set of 8th graders, combined that makes Liberty Middle School, because that's going to combine all the students in our school. If you take all odd numbers and put them in union with the even numbers, well, that will equal whole numbers. Alright, because if you put all the odds and all the evens, that constitutes the whole set of whole numbers. Okay, these ones act a little differently. Okay, what if we take the set of 7th graders and put them in union with all of Liberty Middle School? So if you take all the students in here or all the students in here or both, that still totals up to all of Liberty Middle School for that set. Okay, same thing with this one. If you take all the odd numbers and union them with all of the whole numbers, well, every number that's in here combined with every number that's in here will still just make that set of whole numbers. Okay, alright, for examples, if you could write this down here. Alright, so for a concrete example here, it says if set A contains the elements 3, 4, 5 and set B contains the elements 1, 2, 3, well, set A union with set B, so if we took everything in set A or everything in set B and put them together in union, now the union set would be 1, 2, 3, 4, 5. Okay, like we said in class, a union is like a marriage. You're taking all of one, all of the other, putting it together. Okay, alright, on the shading, if you can draw your Venn diagram here, and set A is this circle, set B is this circle, they did not label this big rectangle. This big rectangle would be the universal set. Okay, so label that because everything is contained in this universal set. Alright, so with your highlighter or something, if you can label this. So to show this union of set A and set B, we would shade all of set A or all of set B. So when we think of the union, I'm shading all of A and all of B. So every element in that shaded region would be the union. Okay? Kind of going to the opposite of that is the intersection. The intersection of A and B is the set of all elements in the universe belonging to both A and B. So the key word here is both or and. Okay? It's only the elements that are in A and B, or both sets, at the same time. And here's how this would be written. Set A intersects set B. Okay, so it's with that symbol. Okay, it's basically the union symbol upside down. Okay? So if we look at some examples here, if we take the set of 7th graders, intersect the set of 8th graders, well, no student is in both 7th and 8th grade, okay, at the same time. Therefore, that answer is the empty set or the null set. If we take the odd numbers and intersect them with the whole numbers, well, the only numbers that are in both sets at the same time would be just the odd numbers, okay? If we take the set of 7th graders, intersect with Liberty, the only students in both sets would just be the 8th graders, okay? So that's how that works here. So if we can write this example on your notes, all right? If set A has the elements 3, 4, 5, and if set B has the elements 1, 2, 3, well, the only elements that are in both set A or set B, or that are in the intersection, would just be 3. That's the only element in that intersecting set. Okay? Just a little something for you to think about here. If set A is the empty set, and if set B has the elements 10, 20, 30, and we wanted to find the intersection, well, the intersection, or the only things that are in both set A and set B, would be the empty set. Remember how we said the empty set's a subset of every set? So the only thing here, I mean, there's nothing. This is empty. Although there are 3 elements, there's technically always that empty set. So that's the only thing that is in both sets at the same time. Alright, so if we were to show this visually, so once again, draw your Venn diagram. And once again, we have to label this rectangle as the universal set because everything is contained in that universal set. So if we shade the intersection of set A and set B, we want to shade the part where the elements will be where they are in both set A and set B at the same time. And that would just be this little football shape in the middle. Okay? So that's the intersection. That's how it looks different from the union. Okay? Alright, lastly, the complement. The complement of a set is the set of all elements in the universe which are not in set A. Alright, so this is basically like thinking opposite. Like whatever's in A, if you want the complement, you want everything not in A. Okay? And there's 2 ways to write the complement. If we're talking about set A, we would put a capital A with a line over it, or a capital A with an apostrophe after it. Both of those mean the complement. Okay? So for some examples, the complement of 7th grade students, so if you think about that meaning everything that's not a 7th grade student, that would be the set of 8th grade students. If we think about the complement of C lunch, that means everyone who's not on C lunch. Well, that set would be everyone in A, B, or D lunch. Alright, so that's kind of how the universal set works. So, I'm sorry, the complement works. For your example in your notes, if you could copy this down, okay? If our universal set, so if everything in our universal set is 1 through 10, if those are our elements 1 through 10, and if set A only has the elements 3, 4, 5, well, that means the complement of A is everything that is not in A. Therefore, because this is an A, because this is an A, and this is an A, we don't include those. We include everything that's not an A. So it would be 1, 2, 6, 7, 8, 9, 10. Alright? And that's how the complement works. Okay? As far as shading it goes, okay, we're only going to shade one of these examples, but draw your Venn diagram in that box again. Here's the universal set. So if I'm going to shade, we're going to do this one. Shade the complement of A. That means I want everything not in A. So let me just find A first. So if this is A inside of it, I want everything not in A. And that even includes, by the way, that the universal set is still part of the problem. Okay, it's not just the circles. Alright, so if I shade this properly, I'm going to get everything that's not in A. So I'm going to get this part of B that doesn't intersect with A, as well as the universal set. So that everything in that shaded part would be the complement of A. Okay? Alright, So guys, go over those notes. It's a lot of vocab, but we'll practice that.